Welcome back to part 2 of your video. Sorry there had to be a part 2. It's a little bit long of a lesson today. So as I was saying, here are going to be all of the numbers that you need to fill in for 3, 4, and 5. So go ahead and take a brief second to do so. Now that you've filled in those numbers, if I wanted to figure out what the 29th sequence was of this, well, I can start creating an equation for it. But the first thing I need to do is figure out where it hits my y-axis at. So in order to figure out where it's going to hit my y-axis at is I need to know at 0 number of dominoes, what is the height instantly going to be? Now I know that sounds a little bit crazy, but bear with me. So instead of multiplying 1.5, we're actually going to work backwards to figure out what the height of no dominoes would be. So I'm going to work it backwards, and the opposite of multiplication is actually division. So what I'm going to do is I'm going to take 5 and divide it by 1.5. And if I do that, what I'm going to get is 3.33 continuing. Okay? So I know that when I graph this, or if I was going to graph it, my height would be, my y-intercept would be 3.3. So if I was actually going to create a function for this, so function f of x equals, I know that my original height is 3.3. And what's going to happen is I'm actually going to multiply that. So I'm going to put a parentheses by what it's increasing each time. So it's increasing by 1.5 times. And since you can see that this is going to be a curved line, because we're multiplying instead of adding or subtracting, we're actually going to put my x to the exponent. Okay? So this is actually going to be my function for this equation. My original height of no dominoes multiplied by how much it's increasing, and the x is whatever number of dominoes there's going to be. So now if I use this, what I can do is plug in my 29, and what's going to happen is I'm basically going to put 1.5 to the power of 29. So when I figure this out, I'm actually going to do it off to the side for you, so that way you don't need to. So if you plug into your calculator 1.5 to the power of 29, what's going to happen is you're going to get 127,834.039. So I still need to, because that's still technically in parentheses, I need to multiply it by 3.3. So if I multiply by my original starting amount, the height that we're going to have at 29 dominoes is 421,852.33. And that's going to be my height. Now, this doesn't sound very tall, but let's actually listen to our video guy. We'll call him Steve. I don't know what his name is, but we'll call him Steve. And let's see what he's going to say about this 29 dominoes and how these dominoes are what they are. So like what their height is and how high would this be? This 421,852.33. So here's Steve. We're just going to call him Steve from the video. Let's see what he has to say.
Ready? Boom. That was 13 dominoes. If I had 29 dominoes, the last domino would be as tall as the Empire State Building.
So there you have it, ladies and gentlemen. Our 29th domino would be as large as the Empire State Building. So let's actually look at what that means compared to other things in the world that we know, like other buildings. So here are some comparisons to show you. So the tallest buildings in the world, right now it's in Dubai as of 2010. Then the next one is in Marica, and then our World Trade Center in New York, the Willis Tower in Chicago, and the Empire State Building. So as you can see, now we're going to actually convert it to feet. So the Empire State Building is probably about 15, maybe 1,450 feet high. So it's super high. This is what the cloud level is, if you can see. So as our world is growing, some countries are creating taller buildings than others, which is totally fine. But obviously the World Trade Center is not around anymore. But anyway, to compare it to all the things that we think are super big, so like the Great Pyramids or the Space Needle is pretty big, the Eiffel Tower is really big, but not compared to these other buildings. So scale to size is key when we're looking at patterns. So how it's increasing, how large it is it constantly increasing by the same amount? Is it arithmetic? Is it geometric? Those kinds of things. So take a second, pause the video, and look at these interesting facts. Look at how many years is in blue it took to build them. The year built is in purple, and the total cost in US dollars that it took to build these buildings. So today we learned about two different types of sequence. As I mentioned a little bit before, we learned about arithmetic sequences. So this is a sequence where we're adding or subtracting from the previous term. So in this case, if I was looking at a pattern 1, 3, 5, and 7, I could see that it's increasing +2 each time. Now there is a different sequence for multiplication and division. That's called geometric. So it's a sequence where we are multiplying and dividing from previous terms. These kinds of sequences, if you remember, they're curved lines. If we were going to graph these sequences, they'd be curved lines, discrete, continuous, those kinds of lines. Arithmetic is more of our regular lines, such as linear, straight lines. So what you're going to do next is you're going to complete this checkpoint number 3. So go ahead and get started on it.